Okay, so first things first is to open Fluid Flow Fluent and make sure our geometry is in 2D. Then open this in the design modeler. Okay, now that we're here, select to see the YX axis and go on the plane. First, gonna make sure we're in inches, because that's the requirement for the specifications. And we'll begin our sketch of the wind tunnel with a line across the axis. We will give that a height. Oops. Height of 15 inches. Then now, gonna make sure it is equal on both sides to the axis by doing that. And we'll begin constructing the other bits. So I'm going to start by making a generic shape of what the tunnel looks like. And the settling chamber has a length of 15 inches. Excuse me, this is supposed to be 22 inches. Yep, there we go. And then now, this is a length of 24. The test section has a length of 12 inches. And the diffuser has a length of 42. Now that we have this with the test section having a height of 6 inches, I will make the distance from here to the axis 3 inches. And now we're given an angle of 3 degrees for the diffuser, between the diffuser and the test section. So this should be 177 degrees. And yep, that is what we need. And now I will try and replicate this across the axis. So I'm going to select our components of the tunnel, replicate it by putting 180 degrees here. And we have it right here. I'm going to flip it to mirror it, kind of, sort of. And not sure why it's not wanting to. Weird. Anyways, place that right there. Hopefully that's connected. Okay. If I draw what's 15? Okay, so I just, instead of replicating it, I just drew it out again, but on the top side. And now that we have this, I will select our sketch. We're going to create a surface from sketches, apply, and now we're going to generate. And here we have our design of the completed wind tunnel. So that should be good. Okay. All right, so here we have our mesh. And I'm going to create a okay, then here for the method, I will change it to triangles. Then we'll generate the mesh. And mesh is looking like this now. And we're going to change this element size here to 0.02 or 0.01, I mean, and generate it again. And here we should have a more accurate mesh. And now I will name our borders. So we'd start off with the inlet. Or, oops. And then our outlet. And then we have the walls of the wind tunnel. Oops. That should be it for our meshing. Looks all good. Now we can get to the setup. And now I make sure it is in double precision. Put on 2 processes and start it. Okay, now that we have our model here, first we're going to make sure it is in a viscous laminar. Select that, press OK. Then our boundary condition, we're going to edit the inlet velocity. And for this project, we need to simulate it for a frequency, a motor frequency of 20 hertz, 40 hertz, and 60 hertz. And we're given the equation to solve for V. And after plugging in into the equation for the 20 hertz, the initial motor frequency, we get a value of 1.25623 meters per second. So we will click apply. And everything else should stay as it is. Then I will initialize. Okay. We will run the calculation. We'll do 2000 iterations and press calculate. And then to get our contours, we will go to graphics. And first we need to grab the contour for static pressure. So it's already selected. We will select the interior. We will select all 4 surfaces and display. And here is our static pressure contour. And okay, and now to see the contour for the total pressure, same thing, but select total pressure. And this is what we get. It looks good. And then now we go to dynamic pressure, which is our last pressure contour that we need. And then we need the velocity as well. So just select velocity, velocity magnitude, display. And here we have it. And then same process again, but with the 20 or the 40 hertz. When you plug it into the equation and solve, you get a value of 2.61387 meters per second. Apply this and just make sure we initialize again. And run our calculation once again. Calculation complete. And we repeat the process again. So pressure, select all 4. Static pressure, save display. Here we go. Again for dynamic. Here's our contour. Total pressure. Here we go. And then for velocity, here we are. Okay, and then now for the XY plots. To do the XY plots, we are going to need to create a new one. Or actually, first we have to create a point. We go here to line rake. And for this, we are going to need the distance from start to finish, so from the inlet to the diffuser. So I will double check that. So our sketching, dimensions. Just to check. L20 is 93 inches, which, if I convert that over to feet, okay, like I was saying, if we convert the total length to meters from inches, 93 inches should give us 2.362 meters. So we go over here to the line rake surface, and we keep this as 0 as we want it to be the center line, but we make x1 equal to the total length. So 2.362 and create. Now that we have that, new XY plot. We'll do it on the line that we created. It should give us our plots. Here's our static pressure at the center line for the total distance. And then same with dynamic pressure and total pressure. And we can also do this for velocity as well. And this XY plot is for the 40 hertz. So it'd be the same process. Just go back to the inlet, change the inlet velocity according to which hertz you're calculating, just initialize again, run the calculation, do the contours, get your XY plots by making the line/rake surface, and that about sums it up. And then these plots you can export to Excel by writing the file, and just write and then just paste it into Excel, and yeah, that about sums it up for the setup part and everything for the project. So yep, that's my video.